All right. So yes, from yesterday, we have one final exercise about the DFA to represent a language, which is a set of strings, binary. The string is a binary number, and it should be divisible by 5, right? As I remember. So anyone can do it? Did you find out the solution for the exercise? Anyone?
Sorry.
Okay,
I
maybe I can
did,
just
but
yeah.
I'm not sure if it cover everything. I'm still testing it.
All right. Okay, maybe I can show everyone my solution. So yes, so the language is a set of string, and it is a binary number, right? And the the important thing is that the number should be divisible by 5. Okay, yeah. So actually, we have to find out the pattern when we add a symbol, because we process string from left to right. So what happened when we add, because our alphabet, we have it is a binary number, so we have only two symbols, 0 and 1. So what happens when we add 0 at the end of like an already existing string? Okay, for example, we have 100, 100. So it is in base 2. If we try to convert it to base 10, according to the formula, we can just 1 multiply by 2 to the power of, this is 0, 1, 2, right? And then plus 0 multiplied by 2 to the power of 1 plus 0 multiplied by 2 to the power of 0. All right. So let's say that we add like one more 0 to the rightmost side of this string W, and then 0. So it will become 1, 0, 0, 0, right? And it will become 1 to the power of 2 plus 0. No, this is to the power of 3. 2 to the power of 2 plus 0 multiplied by 2 to the power of 1 plus 0 multiplied by 2 to the power of 0. And if um, we can also write something like this instead. We get 2 as a factor, so we have something like 1 multiplied by 2 to the power of 2 plus 0 multiplied by 2 to the power of 1 plus 0 multiplied by 2 to the power of 0, right? And then we have the last term here, plus 0 multiplied by 2 to the power of 0. So this is our original W, right? So we can say, we can write 2 multiplied by W in base 10 plus this is 0, right? So we don't have to plus anything. Is it okay for everyone? Do you agree? So what about if we add 1? We can do the same thing, but this is 1 instead. So we will obtain something like 2 multiplied by W in base 10 and then plus 1. Right? Yeah. So now we have this formula in order to compute our number when we add 0 or 1 at the end of our string. So now let's look back at our DFA. So we have maybe I can. Okay, right. I write here instead. So we have W base 2 when we add 0 is equal to 2 multiplied by W in base 10. And W2, if we add 1, it is equal to 2 multiplied by W in base 10 plus 1. Okay? Yeah. So the important point in our exercise is we should focus on divisible by 5. So there are 5 possibilities. There are 5 possibilities, right? So the first possibility is it is divisible by 5. When we do like division by 5, we have 5 possibilities. So we can look at the remainder of the division. When it is divisible by 5, so the remainder is 0, right? So we can write our string in this form. Sorry. 5k, right? This is because it is divisible by 5, so we can write something like this. And k is an integer, right? So for this, when we add 0, by using this formula, so it becomes 2 multiplied by 5k, right? So it will become 10k. And we can write something like 5 multiplied by 2k. So when we do the division between this number and 5, what is the remainder? It is still divisible by 5, right?
It's 0.
Yes. So the remainder is 0, so it is still divisible by 5. So now let's look at the case when we add 1. So it is 2 multiplied by 5k plus 1, right? So it is equal to 5 multiplied by 2k plus 1. So in this case, what is the remainder?
1.
Yes, it is 1, right? Yes, so we can do this way in order to find out the transition from our state. So like I mentioned last time, we can define 5 states. So this is Q0, this is Q1, Q2, Q3, and Q4. So Q0, it means that the remainder is 0. So it is divisible by 5. And this one is to represent the case where the remainder is 1 and 2, 3, and so on. So here we look at the case when our current state, like when the number is divisible by 5. So we are at Q0 now, right? So when we add 0 to the end of our string, we can see that it is still divisible by 5. So it means that Q0, when we do the transition with 0, it is still at Q0. And when we do the transition with 1, it should change state. It should change state from Q0 to Q1. Because you can see here that now the remainder is 1. Okay? So we can now look at the Q1. So for Q1, the form should be like this. 5k plus 1, because the remainder is 1. So when we add 0, it should be 2 multiplied by 5k plus 1. It is equal to what? To 5, 2k plus 2, right? So what is the remainder for this case? It is 2, right? So it means that Q1, when we add 0, so when we do the transition with 0, it changes state to Q2.
Wait, sir. I don't know. I don't understand why. Because we add zeros, so normally we still have the remainder is still 1 because we add 0. Why it is 2?
We can look at this formula. When we add 0, it means that we multiply the number with 2, right? When we convert to base 10. So here's the original number, 5k plus 1. Because it is a number that when we divide by 5, the remainder is 1.
Yeah, okay,
Right?
I get it.
Yes. And when we add
Yes.
0 at the end of this number, so by using this formula, we have this. Right? And when we expand, it is 10k plus 2. 10k plus 2, we can write it in this form instead. So 5 multiplied by 2k plus 2. So you can see that this term is divisible by 5, so the remainder is 2. That is why if we are in Q0, the state is Q0, the current state is Q0. When we add 0, it will change state to Q2 instead. Okay? So now what if we add 1? We can do the same thing. So at the end, we will obtain something like 5, 2k plus 3, right? We can just add 1 at the end here. So 1 plus 2, it is 3. So you can see here that the remainder now is 3. So this one, it changes state to Q3. Okay? So you can do the same thing for all of the states.
I think the state in Q1 is 5k plus 1. And then if you add 1, it's going to be 5k plus 2. And then you multiply by 2, it's going to be 5k.
The formula is like this. 2 multiplied by the number and then plus 1 at the end. So it should be...
Oh, okay, I can see. Okay, sorry.
2 to the... Yes, 5k plus 1 and then plus 1.
Yeah, it was confusing at the beginning too, but yeah, now it makes sense.
Okay. So is it okay now?
But
So now 5k plus 2. So we look at Q2. So this case, the remainder is 2. The same thing, we can add 0. So 2, 5k plus 2. So we can write in the form like 5 multiplied by 2k plus 4, right? So here, something like this. And when we add 1, we will obtain 5, 2k plus 5, right? And then we can write something like 5 multiplied by 2k plus 1. So this one is divisible by 5 again, right? So yes, Q2, when we add 1, we'll change state to Q0. Okay, so you can do the same thing for Q3 and Q4. So we will have a 4 more transition and to complete the DFA. So what is the start state?
Q0.
Q0. And it's
Yes,
also the finish state.
actually that depends. Like when we start, we have empty string, right? Epsilon, empty string. So if we consider that empty string, it is 0, it means 0. So you can, yes, you can choose Q0 to be the start state. But if you think that you have to have at least 1 digit in your number, so maybe we have to add 1 more state. Right? Let's say QS to be the start state. Okay, QS to be Q start. And then when we add 0, so it means that now it is empty. It is epsilon, empty string. So when we add 0, what happens?
It go to Q0.
Yeah, it goes to Q0 because when we add 0, we will have like number 0, right? So number 0, it is divisible by 5. So we will go to Q0. And what about 1?
Goes directly to Q1.
Yes, it will go directly to Q1. Okay. And what are our final states? How many final states should we have? So we want only the number which is divisible by 5.
Only Q0 is the final
Yes,
state.
only Q0 is the final state. Yes, and that is it for the last exercise.
wait, sir. Q5 is divisible by 5. So why it's not why it cannot be the final state too?
So, sorry, what is the question again?
I thought Q5 is divisible by 5, right? So
No, this one
the
is
final state.
QS. Like I want to add a new start state.
Do you want to repeat? I can repeat.
So because at the start we have like a string, like we have this case also. The epsilon is an empty string, so we don't have any digit in this number. So we don't want to accept it. That is why we have like this start state. So unless we have at least 1 digit, and then we can, if it is a 0, so it means it is number 0. So 0 is divisible by 0. Oh, sorry, divisible by 5. So we can accept it at Q0.
Okay, understood. Thank you.
Yeah. And if you consider that when it is empty, it is also 0. So you don't have to have this QS. You can just use Q0 to be the start state. But if we use Q0 to be the start state, the DFA accepts also epsilon, which is an empty string.
Teacher, I still cannot catch it. And in this DFA, which one is the static state? Q0, right, teacher?
Here, QS. QS is the
QS
start
is
state.
the start state. So what if it's the binary number 0 and 0, will it accept?
Yes.
Why, teacher? Because 0 and 0
That's
in the base 10 it's 0, right?
yes. So 0 is divisible by 5.
0 is divisible by 5. We don't start from number 5, right, teacher?
No. We can start from any number. So the number can be smaller than 5. Like, for example, 1. 1, when we divide by 5, the result is 0, right? So, and the remainder is 1.
Yes.
Yeah. And for number 0, when we divide by 0, when we divide by 5, the result is 0, and the remainder is also 0. So 0, we can say that it is divisible by 5 as well. So if we write something like 0, 0, it means number 0, right? So it should be accepted by our DFA because it is divisible by 5. And when we look at this DFA, you can see that the first 0, we transition from QS to Q0. And when we add another 0, you can see that it loops. We have a loop here. So it is still at Q0. So
Okay,
it is accepted.
got it, teacher.
លោកគ្រូអាចជួយបញ្យល់តិចមកខ្ញុំអត់សូវច្បាស់ divisible by 5 ហ្នឹងចង់មានថាវាចែកដាច់នឹង5ហ្នឹង
ហ្នឹងហើយចែកដាច់នឹង5ចែកដាច់នឹង5
បើសិនជាចែកដាច់នឹង5ហើយចម្ងល់វា
បើចែកដាច់នឹង5យើងអត់សឹកបើអត់ចែកដាច់នឹង5ទេយើងអត់អត់សឹកទេសម្រាប់ DFA របស់យើងអញ្ចឹងកន្លែងហ្នឹងវាអាច confusing តិចដោយសារពេលដែលយើងនិយាយពី string វាអាចមានចាប់ដើម string ដែលតូចជាងគេគឺ epsilon មិនអញ្ចឹងបានតែវាមាន symbol សោះនៅក្នុងហ្នឹងអញ្ចឹងហើយបាទខ្ញុំកន្លែងហ្នឹងខ្ញុំបន្ថែមអា QS នេះមកមួយទៀតដើម្បីកុំឲ្យវាអត់សឹកអា epsilon ហ្នឹងពីព្រោះបើអត់មានអីសោះយើងអត់ចាត់ទុកថាវាថាជាលេខ0ទេមិនអញ្ចឹងបានតែយើងចាត់ទុកវាជាលេខតើតើវាមានយ៉ាងហោចណាស់មក digit នៅក្នុងហ្នឹងអត់ទេថាឥឡូវបើសិនជាយើងចាត់ទុកថា epsilon ហ្នឹងលេខ0ដែរស្មើនឹងលេខ0ដែរអញ្ចឹងយើងអត់ចាំបាច់ថែមអា QS ទេក៏បានតែយើងអាចយក Q0 ហ្នឹងជា start state យកតែម្ដងទៅអាហ្នឹងក៏អូខេដែរប៉ុន្តែបើសិនជាយើងគិតថាយ៉ាងហោចណាស់ត្រូវមានមួយ digit នៅក្នុង number អញ្ចឹងបើយើងអាច accept បានអាហ្នឹងតើតើយើងបន្ថែមមក QS នេះមកអូខេOkay, so this DFA is not complete yet, right? So you have to find out transition from Q3 and Q4 by doing the same thing here. Yeah.
លោកគ្រូខ្ញុំចង់សុំអា Q0 ហ្នឹងវាបើវាស្មើ0អញ្ចឹងវា divide មួយ5បានហ្នឹង
ហើយយើងលេខ0ចែកដាច់នឹង5ណាលេខ0ណាមិនបានន័យថាលេខដែលចែកនឹង5តោះតែធំជាង5ឯលេខតូចជាង5លេខ integer ដែលតូចជាង5ក៏យើងអាចចែកនឹង5ហើយយកសំណល់បានដែរលេខ1អញ្ចឹង1ចែក5នៅសល់1អញ្ចឹង
Teacher, I think the number 15 which is that binary number is 1111. Will it accept? Yeah, that's it. Can you check it? with the DFA.
Okay, so we have 1 and then 1. Okay, because we haven't completed our DFA yet, actually. Okay, so let's try to complete it. Only 2 more, right? So we have 5k plus 3 for the case of Q3. So when we add 0, so it is 2, 5k plus 3. So it is equal to 10k plus 6, right? So it is equal to 5, 2k plus 1, and then plus 1, right? So 10k plus 5 plus 1, it is plus 6. And when we add 1, it should be 5, 2k plus 1, and then plus 2. So it means that Q3, when it reaches 0, it moves to Q1. And then when it reaches 1, it moves to Q2. Okay, the last one, 5k plus 4. So when we add 0, we have something like 2, 5k plus 4, 10k plus 8, which is equal to 5, 2k plus 1, and then plus 3, right? In order to obtain 8. And when we add 1, it should have something like 5, 2k plus 1, and then plus 4. Okay. So for Q4, 0 to Q3, and 1 to Q4. Okay, so let's try to test 1, 1, 1, 1. So it is 15. 15 should be divisible by 5. So the first one from QS to Q1, and then from Q1 to Q3, and then to Q1 again.
Maybe you should go to Q2 and then Q2 to Q4.
I confused the. Okay, so what is this one? This one is 1, right? Yes, this one is 1. So the first one is Q1, and then Q3, and then Q2, and then Q0. You see, it returns back to Q0. So this one is a subject.
Again, please, teacher.
Okay. So we have 1, 1, 1, 1 4 times.
Yes.
So we start from QS. You can see that transition by 1. So we have 1, 1, 1, 1, right? So the first one, it transitions from QS to Q1. And then the second one from Q1 to Q3. And then the third one from Q3 to Q2. And the last one from Q2 to Q0. So you can see that it arrives at final state. So this one is a subject, which is what we want, right? Because 4 ones in base 2, it is equal to 15 in base 10. So 15 is divisible by 5. Is it clear?
Okay, teacher, I got it.
Okay, so yes, I think that is it for lesson number 1 about definition of language, and also we can see one notation, which is the final automaton that we can use to represent language. Any final question about the first lesson before we can move on to the next lesson?
Teacher, if if we don't include zero, except zero. Sorry, sir.
I have also a question.
Okay. Any other questions? All right. If there's no question, we can move on to lesson number 2.
Teacher,
I have already uploaded. Yes.
There are 2 questions. First from my classmate. Maybe you can ask again your question.
Okay. Yes. What is the question?
I think he might be one. He meant that
Can it be?
if the accepted string is bigger than 5, I mean start from 5, not start from 0.
It can start from any number. The input string is not in base 10. The input string is in base 2. It is a binary number. And it can start from any number, because a binary number, it can start from 0, right?
No, I'm just assume that it's my classmate question.
Okay.
Now, my question was, can it be for the final exam? Can it be like harder than that, or is it the maximum that we can have in terms of difficulty?
The maximum what? I cannot really catch your question.
The difficulty, can it be harder for the final exam?
Ah, you mean for this one? Yes, it can be.
Okay, just for fun, just for my. Okay, thank you.
លោកគ្រូខ្ញុំសូមជឿឥឡូវវាត្រូវ start ពី 0 ទៅមែនលោកគ្រូ
ហ្នឹងហើយដោយសារកន្លែងនេះបានន័យថា alphabet យើងគឺ x ស្មើទៅនឹង01ត្រូវទេអញ្ចឹងបានន័យថា DFA របស់យើងអាច process string ណាក៏ដោយឲ្យតែផ្គុំឡើងពី0ហើយនឹង1អញ្ចឹងវាថាតើ0ទៅទេអញ្ចឹងក៏យើងអាច process បានដែរមិនអញ្ចឹងថាតើវាaccept ឬក៏មិន accept តែអញ្ចឹងក៏យើងសុំច្រឡំកន្លែងនេះបានន័យថាយើងចែកនឹង5ហ្នឹងគោល10ប៉ុន្តែ input string ដែលយើងយកមក process ដោយសារ DFA របស់យើងហ្នឹងវាជា binary number អញ្ចឹងវាមានតែ0ហើយនឹង1ណាក្នុងហ្នឹងហើយអាចជាលេខអីក៏ដោយលេខអីក៏បានដែរឲ្យតែផ្គុំឡើងពី0ហើយនឹង1
ខ្ញុំមើលទៅបើវា start ពី S Q S ទៅវា1ហើយដល់ពេលវាត្រូវបាន0ទៀតវា Q2 វាអត់ accept
ណែព្រោះ10ស្មើប៉ុន្មាន10មិនមែន10ទេ10គោល2ស្មើប៉ុន្មានគោល10
អាហ្នឹងគោល2ខ្ញុំច្រឡំខ្ញុំស្មានដែរឥឡូវ
ហ្នឹងហើយយើងក៏បានថា input string ជា base 2បន្ទាប់មកពេលយើងនិយាយថាចែកដាក់នឹង5ហ្នឹងតតែយើងបំលែងវាជាគោល10សិនបាទយើងដឹងថាតើវាចែកដាក់នឹង5អត់មិនអញ្ចឹងយើងទៅថា10ហ្នឹង10គោល2ដល់ពេលយើងវា2គោល10មិនអញ្ចឹង2អត់ចែកដាក់នឹង5ទេ
បាទលោកគ្រូ
Okay so I think that បាទ
លោកខ្ញុំចង់សួរមួយទៀតឧទាហរណ៍បើសិនជាយើងអត់accept 0ក្នុងការចែកដាច់នឹង5ហ្នឹងតើអាចនឹង DFA យើងមួយណាជា final វិញលោកគ្រូ
So it means that so yes, I think so the question is that we don't want to accept 0. So it becomes another language entirely. So let's say that this is our language. So the new language is equal to the language, our language, the language to represent a set of string divisible by 5, and then minus 0. And not just 1 0, right? It can be any number of zeros. So it can be something like minus 0 to the power of n, right? Something like this. So this is the language that you want, right? So when we define this, like when we want to define a DFA to represent this language, yes, I'm not sure. You might have to add like more states.
Actually, I did that one for the first one. I didn't accept 0. So all you have to do is add one more state and let all the transaction that point to Q0 point to that new state, and then you can give that state as a final state, and that's it.
Okay. Yes.
Okay.
So probably yes. Probably yes. So we have to add more state, or we have to change something. Just that. I want to clarify that when we do something like this, it is an entire new language. So the number of states and the transition can also be changed as well. Okay, yeah. Okay, so I think almost 1 hour already. Maybe we can now move on to the next lesson about text processing. I have uploaded the slides to Microsoft Teams already, so you can download and read them. All right, so I will share my slide. Okay, do you see my share slides?
Yes, teacher.
Okay, yeah. So lesson number 2 is about text processing. So in this lesson, we will talk about a number of different techniques that we can use in order to process text. Okay, so the first thing that we can think about is regular expressions. Okay, so regular expression, it is an expression that we can use to especially to search for a specific pattern in a body of text. And we can also, it is also useful when we want to replace like a pattern with a new pattern. Okay, have you ever heard about regular expression? Actually, in the course automata theory, we also talk about regular expression, but it is more on the concept. Okay, So for in this lesson, when we talk about regular expression, we talk about pattern of the text. Okay, yeah. So we can use these are the basic notation in a regular expression. So if we use dot, it means that it can be any character. Okay. Any character here, it includes all of the character in the ASCII code. And then we have something like this, backwards slash and then W. So you can see this is a lowercase w, lowercase d, and lowercase s. It is to represent word. Word here, it means that letter plus digit. Letter plus digit. So letter A to Z and digit 0 to 9. And slash D only digit. And S, it represents space. Slash S. And if we use the capital letter instead of lowercase letter, it means not instead. So uppercase or capital W, it means that to represent any character that is not a word character. So it is not a letter and it is not a digit as well. And slash capital D, not a digit. Slash capital S, not a space. Okay. And then we have this one, A, B, C, and then we put it inside bracket. So any symbol that we write inside the bracket, it means any of the symbol that we write in the bracket. Okay, so here we write 3 symbols, A, B, and C. So it means that this one represents only one character, but it can be either A, B, or C. And inside the bracket, if we use this notation, this symbol, the head symbol here, at the beginning of the bracket, it means not instead. So this one, it means that any character beside A, B, or C. And last, we can use also dash to represent range. So here, instead of writing A, B, C, D, E, F, G, we can just write A dash G. So it means that any letter between A and G. Okay. Okay. The next one, we have operations such as star, plus, and then a question mark. So if we put star on the right side of a symbol, it means that we can repeat that symbol multiple times. And it can also be 0 times. So you remember the closure operations in the first lesson. So it is just like that. So here it represents like a sequence of A. And because we put star, it means that we don't have to have an A. It can start from 0, the number of A. And if we want to have at least one A, we can use a plus instead. Okay, so star 0 or more, plus sign 1 or more. And if we put question mark, it means that the letter A is optional. You can see 0 or 1. Okay, and if we want to specify an exact number of the symbols, we can put the number inside the curly bracket. So you can see here, it means that we must have a sequence of A with 5 A's, exactly 5 A's. The sequence of A has exactly 5 A's. And we also use something like this, 2 and then comma, and then we don't have to put anything here. It means that at least 2A. Okay, so 2 or more A's. And we also can limit both ends. So here you can see that it is at least 1 and at most 3. Okay, and here is the question mark again. If we put the question mark after like all of these, it means that match as few as possible. So let's say that if we have our text like A5 times, okay, and we write our regular expression to be A and then 3. So here it means that it represents a sequence of A with at least 3. Like the number of A's has to be at least 3. So does this pattern match this text or not?
Yeah.
Yes, it matches this text, right? So it will return all 5 A's as the result. But if we put something like question mark at the end, so it means that we want to have like the length of the text needs to be as small as possible. So if you put the question mark here, it means that it match only the first 3A here. Okay.
So
Yeah.
it should be 5 instead of 3.
If we don't put question mark at the end, we match the whole text. So 5 A's. Because you can see that it is at least 3 or more.
Yes.
If we put question mark, it means that we have to match as few as possible. So the shortest text from this one that we can match is 3 A's, because you can see that at least 3. So if we put question mark at the end, the pattern or the text that we match is only 3 A's, not the whole text.
Okay.
Teacher, how about A plus question mark?
A plus question mark, so only 1 A.
Oh, okay, got it.
Yeah. And the last one, we can also use this operator, the pipe operator. It means or. Okay, so you can see that it is A, B, or C, D. Okay. Next, we have escape character, because we have some special character that we can use in our regular expressions, such as a dot. It means any character, right? So if we want to put like the real dot sign in our regular expression, we can use a backward slash in front of it. So this one, it becomes just like the dot sign. it doesn't represent like any character anymore. The same thing for star, plus, and other special characters that we use in our regular expression. Okay? And also we have a backward slash t, backward slash n, and backward slash o. It is to represent this is tab, and this is a new line. And slash o, it is new line as well. And anyone knows the difference between slash n and slash o?
No, teacher.
Yes. Okay. So yes, actually, sometimes they are interchangeable. It means that they represent a new line. But for example, slash o, it is used in the old Mac OS. But I think after Mac OS X, they changed from slash o to slash n as well. And in some application, slash n is to move the cursor to the beginning of the next line. For example, if we have a line like this, and we are right here, if we see the slash n character, it will move our cursor to here. You see the beginning of the next line. And for slash o, actually it will return the cursor to the beginning of the current line. And so it will move to here instead. And so this is slash o backward slash o, and this one is backward slash n. Okay, and sometimes both of them can be used together as well. For example, slash or slash n in order to represent like a new line. So yes, I think slash n is more common now. So yes, if you want to represent a new line, you can use backward slash n. And next we have anchors. So for anchors, we have this one and this one as well. So this one, when we put this in our regular expression, so it means that the pattern needs to be at the beginning of the text. And for the dollar signs, it means that the pattern needs to be at the end of the text. And backward slash b, it represents like the word boundary. So it means that the right after space. For example, we have something like in our text, I go to school. Okay, so this right here, it is backward slash b. Right here as well, backward slash b. Okay, so it is a word boundary.
backward slash B ហើយនិង backward slash W នោះវាខុសគ្នាត្រង់ថា backward slash W និង space ទៅលោកគ្រូ
Backward slash W, it represents any letter or any digit. You mean backward slash S?
បាទគ្រូបាទ
backward slash S ហ្នឹងគឺ space.
តែឥឡូវនេះអាចប្រើ backward slash S បានតែលោកគ្រូមិនបាច់ប្រើ backward slash B ពីរដងអញ្ចឹងលោកគ្រូ
អត់ទេចាំមើលអា backward slash b ហ្នឹងបានន័យថាវាមិនមែនជា space ហ្នឹងទេអញ្ចឹងចង់សំដៅទៅកន្លែង position នេះបើយើង print មកអា backward slash b នោះអត់មានចេញអីមកគឺវា empty ហ្មង ប៉ុន្តែចង់សំដៅលើ position ដែលគេថាជា cam នៃ word របស់យើងជា boundary នៃ word របស់យើងដល់ពេល backward slash s នេះអាហ្នឹងគឺជា space តែម្ដងចាំបើយើងវា print វាចេញមកគឺវា space វាដក clear តែនេះអានេះយើង print មកមើលអត់ឃើញទេហ្នឹងដោយសារវា represent boundary
បាទគ្រូបាទអរគុណលោកគ្រូ
លោកគ្រូសរសេរអីមែនខ្ញុំដូចឃើញតែ slide អត់មានឃើញគ្រូសរសេរអី
ខ្ញុំទៅសេលើហ្នឹងតាអ្នកផ្សេងមើលឃើញទេ
ឃើញលោកគ្រូ
អូខេ
slow ដល់
លោកគ្រូ backward slash b ហ្នឹងទាំងមុខទាំងកែមខាងមុខខាងក្រោយឬក៏តែខាងក្រោយ
ទាំងមុខទាំងក្រោយនិយាយទៅគេហៅថា backward slash b it represents like the beginning of the word and also the end of the word so it is the boundary of the word okay so the last one is about group and look around so we can also use parentheses in order to group just like in like arithmetical expression we can use parentheses in order to group some operations together so the same thing here in regular expression we can use parentheses as well but it also has another benefit like we can use the parentheses as a capture group. By capture group, it means that we can reference it later in our expression. Okay, for example, if I have something like this is the regular expression. Like I am, let's say something here, it is a sequence of words, so I can just write something like this /s, so this is space. Or actually, in regular expression, we can also use space as well. So if you don't want to use /s, you can just like a type space. So maybe in order to not to be very complicated, I can just use space directly. Let's say I have a sentence. So this is my regular expression. You are, and here I put a dash z plus. Okay, and I put it inside a pair of parentheses. So it means that this is group 1. And then I am even. And then here you can see that we can back reference to the pattern that we have group, that we have capture. So this is a group number 1 in our expression. So we can back reference to that group by writing backward slash and then the number. For example, if we have multiple groups, so the order is from 1, 2, 3, and so on. So because here we have only one group, so we can back reference by using backward slash 1. And then maybe I can write ER at the end. And then, yes, and then that's it.
Sir, I have a question. So my question is, so for example, the first group is you are a good student. So for the when you make a back reference to the first group, does it mean that it has to be the same? So good student, or can it be another thing?
Yes. That's what I want to show you. So this is the regular expression. So I can show you the text that it matches. So the text that it matches, maybe you can use something like you are strong. I am even. You can see that it back reference to the first group here. So if this one is strong, this one should be strong as well. And then we put er at the end. So this one, this regular expression, it matches this text. But if you write something like you are strong, I am even, like something like ABC, ER. So it doesn't match. You can see that even though it back reference to this one is A dash Z. So any letter from A to Z and then plus. So any sequence consisting of letter A from letter A to Z. So you can see that ABC also satisfies this pattern, but because we use a back reference, so like this has to be the same, exactly the same as the text that we see in this group, in this location. Okay, so this one is strong. This one needs to be strong as well, so that the text can match, or the regular expression can match the text.
Sir, I have a question. So.
Okay, yes, go ahead.
So you add er at the end, so it matches the strong, right? Stronger. But can we add another word because it will still match? Because we just add other letters. So maybe I am even stronger and better. Does it still match, or does it, and why?
Yes, actually, these are all part of our regular expression, like YOU. So if you want to add, it is okay, like and better, something like this. So in order to match this pattern, so we have in our text, it also has to end with and better.
Okay.
Okay. So this is our regular expression. And these are the text.
Teacher, it's possible that we use a slash like a back reference to group before, like we have group one, like you are /1 MA1, like group
No. We
cannot.
have to have the group first in order to have the number so that we can back reference to. And you can see that I put here, it is very useful with replace. Because when you want to replace like a substring with another substring, with a string with another string, for the function replace, you have to put two patterns. Okay, something like pattern number 1, and then you have to provide pattern number 2, and then the text that we want to replace, right? So this is the body of text, the whole text. And this is the pattern of the string, the old string. And P2, it is the pattern of the new string. So we want to replace all pattern 1 with pattern 2 instead. So for this case, we can use group, capture group in pattern number 1, and then we can use the back reference in pattern number 2. Okay. I think in order to understand better, maybe we can see some, yeah, maybe we can use Python in order to try to compile and try to, yes, execute the regular expression. Maybe it is better to understand that way. Okay, I can share my screen again. Drive. Okay, so we can use Google Colab in order to run our Python code. So are you familiar with Google Colab, everyone? Do you know Google Colab? Do you know a Jupyter Notebook?
No.
Yes. Okay, it is like a Python environment that you can execute, or you can code and then you can run your code online. It is one of the feature of Google. So if you have a Google Drive, you can just create a Jupyter Notebook, like right here. I can right click and then more, and then you can see here Google Collaboratory. Yeah, and we will have something like this, and then you can write your Python code here. Okay, so in order to execute to work with regular expression in Python, we have a package called OE. So we have to import it first. Okay, so let's try to run it so that it can we can use the autocomplete in our function. Okay, so let's say that we have okay, so you can in order to see all of the functions that we can use in this package, you can just Google it, like Python OE. Python, not Python, no. Okay, you see the documentation of Python, and you will see that we have a lot of functions that we can use. Okay, my internet is slow. Okay, why is this? What? Okay, so here is the documentation of the regular expression package, and you can see we have some explanation about the regular expression notations that I have shown you already, the basic one. And we can look at the function. Maybe we can look at yes, match. So match, you can see that we can put pattern and then the text that we want to test if it matches our pattern or not. Okay, so let's use this one. So in our code, we can first write our pattern first. So in order to state that it is a regular expression pattern, we can write O, and then we put our regular expression between like quote or double quote. Okay, so let's write something like a sequence of letter, and then at the end it has to be a digit. Okay, so you can see here that this one, it represents any letter, lowercase or uppercase. And then we put plus, it means that one or more. And at the end, backward slash D, it means that it has to be a digit at the end of our string. Okay, so now let's our touch, it is something like A, B, C, D, E, F, and then number 0 at the end. So you can see that this one matches our pattern. We can like a result is equal to OE dot match pattern text. Then we try to print the result. Okay, you can see that it returned this match object. And you can see that it matched from index 0 to 7. So 0 to 7. So the whole thing matches the pattern. So let's put another text that does not match our pattern. Let's say that it ends in a letter instead, like G at the end. So when we run again, okay. For this one, match is you can see in the documentation. We have actually in Python we have a match and also I think exact match.
I think you mean full match.
Yes, full match. Yes, full match. So full match, it means that the whole text needs to match our regular expression. But if we use just match, it means that if the beginning of the text matches our regular expression, it also return. It is also how to say it returns the object. It means that it considers to be to be matching the pattern as well. You can see here that here's my Google App. You can see because this is our text and the beginning of our text, you can see that it matches the regular expression. So you can see that it returns that this substring from our text, it matches the regular expression. And you can see the span here, it is the index of the text from our the index of the match substring that we extracted from the whole text. You can see that now we have 0, 1, 2, 3 until 8, right? But you can see that it match only from 0 to 7. If we use full match instead, so you will see that it will return none because the whole text does not match the regular expression. Okay. Is it okay, everyone, for this one?
Yes.
Actually, you can also use like one website in order to visualize better the regular expression. I think it is called Rec 8101. Okay, this website. And then you can just write your regular expression here. So we have A, Z, plus, and then backward slash D. Okay, so if I write something like A, B, C, D, E, you see, and if I add 0, it is highlighted in blue. So it means that this string matches our regular expression. If I add like other character, it doesn't match anymore. At 0, it match again. Because here we use here the flag global here, so it means that it will try to find because yes, let me move back to Python. If we use a like full match or match, it match only one time. Like if you want to try all of the occurrences of the pattern inside your text, you can use another function. I think it is called find all. Result is, or if find all, like for example GHIJK, and then I add 1 again. So you can see that we have 2 substring that matches this pattern. So this is 1, and this is the second one, right? Okay, so if we use a match, it will return only the substring, the match substring from the beginning of our text. So this one. I use match also full match, so just match. See, you see, only from index 0 to 7, and it will return this one. But if we use find all, okay, it returns 2 substring, this one and this one. So in this website, it is like find all. So it will try to find in the whole text all of the substring that matches this actual expression.
ចុះលោកគ្រូយើងមានអាចមានវិធីមួយទៀតដែលអាចថាពី a តូចដល់ធំក្នុងនោះពីតម្លៃ0ដល់9អាចធ្វើយ៉ាងបានដែរលោក
ហ្នឹងហើយឧទាហរណ៍ឥឡូវយើងចង់ថាកន្លែងនេះ any ទេយើងអាចដាក់ថែម0ដល់9ទេក៏បាន
បាទអរគុណលោកគ្រូ
Okay, so if you add 0 until 9 like this, so in this bracket it means that any character, any letter, any lowercase letter, any uppercase letter, and also any digit. So you can see that now the whole text matches this pattern because it ends the last digit of this string is a digit. So the whole string matches this regular expression. You can also use backward /d inside the bracket as well. It is the same thing. So backwards /d, it is the same thing as bracket 0-9.
Look through some số mùi backwards /d ហ្នឹងវាយកបានតែ integer number តែហើយវាអត់យក floating ណាលោកគ្រូ
ហ្នឹងហើយ only like one character. /d represent only one character. But it can be the character can be any digit from 0 to 9. Cái này nó dân côngច្រឡំថា /d ហ្នឹង represent like a sequence of digit /d ហ្នឹងបានថាតែមួយ digit ទេបើសិនជាយើងចង់ represent a sequence of digit, if you want to write a regular expression to represent a sequence of digit, you must write /d and then plus. So 1 2 3 and then so now we have 3 sequences of digits. So it matches this regular expression. if only one, you can see that now we have only one digit. A single digit will match this regular expression. Okay. All right. Maybe I can. Okay, so we are here. So is it okay for capture group and also the back reference? So here maybe I can also give some example about group capture group and back reference here. Like go back to this website. Like okay, so maybe I can just write adword /d and then plus, and then like ABC. And if I use backward/1 here, so you can see that backward/d plus here, it is a regular expression, and I write it inside the parentheses. So it means that this is group number 1. And if I write backward/1 here, so it means that in order to match this pattern, we have to have like first a sequence of a digit. So let's say 1, 2, 3, 4, 5, and then A, B, C. And you can see this is a backward/1. So we have to have exactly the same sequence here at the end of the string. So 1, 2, 3, 4, 5. Okay, so you can see that now it matches our regular expression. If it is not exactly the same, it doesn't match, even though it is a sequence of digit as well. But it is not exactly the same, so it doesn't match. Okay, and we can have multiple group in one regular expression. Let's say that this one is all letter. Yes.
គ្រូមិញខ្ញុំដាក់ដូចលោកគ្រូទៅវាដាក់ match ប៉ុន្តែវា match តែខ្ញុំដាក់លេខបន្ថែមទៀតលោកគ្រូខ្ញុំចង់ដឹងលោកគ្រូប្រើ select function ដូរកន្លែងណាវិញដោយអាតវងលោកគ្រូដាក់ find all មកទេលោកគ្រូវាដូរកន្លែងណាคลิกអត់តាមអត់តាន់
យើងតេស្តនៅក្នុង website ហ្នឹងដែរក៏តេស្តនៅក្នុង Python
ខ្ញុំតេស្តនៅ website ដែរលោកគ្រូ
នេះកន្លែងនេះបើយើងដាក់ global បានន័យថាវានឹងដូច find all អញ្ចឹងបើមិនជាយើងដក global ហ្នឹងអញ្ចឹងវា find តែ the first occurrence ទេ
បាទលោកគ្រូតែអញ្ចឹងដាក់ m វិញមែនលោកគ្រូ
បើ m នេះបានន័យថាវា find តែ the first occurrence ទេបើមិនជាយើងដាក់ global មាន g នេះទៀតបានន័យថាវា find បើមិនជាវាមាន occurrence នឹងច្រើនដងវា find ទាំងអស់Okay, so now I add like a second group. So this one is a sequence of uppercase letters. So let's say, and let's say I put /2 first and then /1 later. So you can see here that /2 here back reference to the second group here. Okay, so in order to match, it should be here AB. Okay, so you can see here, this is the first group and this is the second group. And after ABC, the second group should be here first. So AB and then 1, 2, 3, 4, 5 later. So this is how we can use yes, capture group and group capture and back reference in our regular expression.
លោកគ្រូសាក់ time នៅក្រោយទៀតមកលោកគ្រូ time លេខ1លេខ2លេខ3លេខ4លេខ5បាទលោកគ្រូ អញ្ចឹងអាហ្នឹងវាមានដែរដោយសារតែយើងប្រើអា MG មែនលោកគ្រូ
Yes នឹងដោយសារយើងប្រើអត់ទេអត់ប្រើ global ហ្នឹងក៏វា match ដោយសារវា match អានេះវាមានតែមួយ occurrence ឥឡូវទៀតថាឥឡូវខ្ញុំបន្ថែម occurrence ទៀតថា333បន្តមក AA ហើយបន្តមកយើងត្រូវមាន ABC នៅកណ្ដាលហើយ AA ទៀតហើយ333វិញអូខេយើងឃើញឥឡូវយើងមានដល់ទៅ2 occurrences we have now 2 occurrences that match our regular expression so it returns both occurrences because in this website we use the tag global here so it returns all of the occurrences if we remove this one it returns only the first occurrence so yes so this one it corresponds to it is equivalent as a function match in Python and if we add global here it is find all okay yeah and I recommend that you try to read this page which is the documentation about regular expression in Python and you will understand more about how to use each of the function okay so we have a lot more like we have search we have match and what are the differences between all of these functions we have also replace I think no in this one it is called sub instead so this one it is to replace you can see that we have to put in 2 patterns okay the first pattern the second patterns and the text so this is what I mentioned before like the capture group it is useful in this case so you can use a capture group in the first pattern and then you can back reference in the second pattern okay maybe I can give some example about this one let's say where's my code here so yes I have this text is equal to like 1 2 3 4 5 6 7 8 9 so we have 9 numbers and we want to put dash after 3 digits we put dash and after 3 more digits we put another dash it is like the format the phone number format okay to be something like this instead 1 2 3 and then dash and then 3 more digits 4 5 6 another dash and then at the end 7 8 9 so how can we do that so here in order to do that we can just use pattern number 1 which is to match the sequence of 9 digits so we can write something like actually we can write something like /d and then 9 right so this particular regular expression matches this text but actually we don't want that we want to group the digit into 3 groups of 3 digits so we should write something like this instead okay so this is the first group we have to put it inside the parentheses the second group also 3 digits And the third group also 3 digits. Now we have 3 groups. So for pattern number 2, when we see pattern number 1, we want to replace it with pattern number 2 instead. So it should be, we want to put dash in the middle, right? So we can just use a reference. So group 1 and then dash, and then group 2 and then dash again, and then group number 3. Okay. And then we can just write something like result is equal to OE dot sub pattern 1, pattern 2, and then our text. You see? Now yes, we will have what we want. So you can see that capture group, it is useful, very useful in the replace functions. And in this package, we have this function called substitute, which also means to replace. Is it clear for this point?
Yes, teacher.
Any question?
លោកគ្រូចុះបើយើងដាក់4 5 6វិញយើងដូរកន្លែង P2 ហ្នឹងដាក់អា /2 មកមុខវិញមែនលោកគ្រូ
4 5 6មិនវិញចង់និយាយថាយក group ហ្នឹងហើយអាហ្នឹងវាគិតតាម order ដោយសារនេះយើងឃើញថានេះ group បាន3 digit ទី1នេះ3 digit ដំបូងនេះអាហ្នឹង group ទី1 3 digit បន្ទាប់ group ទី2អានេះ group ទី3អញ្ចឹងអាហ្នឹងវាគិតតាមអាហ្នឹងអញ្ចឹងបើសិនជាទៅតាមកន្លែងនេះយើងដូរទៅជា3អានេះទៅជា2វិញប្រកបជាយើងឃើញ result មកចេញពីអញ្ចឹង so it is very flexible. You can do a lot of things with this capture group feature. Okay. So so we can continue about yes, non-capturing. So sometimes we just want to group the regular expression together, but we don't want it to be we don't want to back reference to it. So we can use this notation at the beginning of the group. So question mark, then colon, yeah, question mark and then colon. So when we see something like this, it is just only for grouping and not for back referencing. Okay, so let's look at this. Maybe I can write something like I do not want to back reference the first group here, so I can just write question mark colon. Okay, so the first group here it is not it is just only for grouping. It won't be used as a reference later. Okay, so this group will become the first group. So you can see that it is error. We do not have 2 groups. We have only two group. We only have 1 group that we can back reference to. Okay, so for backward slash number 1 here, it back reference to this group and not this group, because this group we put the question mark colon. So this is like only for grouping. Okay. What's next? So we have a look ahead. So yes, this is an even more advanced feature in the regular expression. So for look ahead, maybe I can give you an example. So we have a positive look ahead and negative look ahead. Let's write something in our example. Let's like okay, so something like Phnom. And then if I write something like it is a positive look ahead. And then in our text, we can write Phnom Penh. You can see that the word Phnom here, it matches our regular expression. It is like a condition, like it has to match this regular expression, and also like this one needs to be followed by this expression. Okay, but it is not the entire text Phnom Penh. It returns only Phnom, because in our regular expression we focus only on Phnom here, and this part is just like a condition that we need to fulfill. So let's say we have another Phnom, and like Phnom, or something like this. Okay, you can see that it returns only, even though we turn on the global flag. You can see that it returns only the first Phnom here. Like here, Phnom Penh again. You see, it returns this one and this one, but not this one, because this one does not satisfy this condition. Because Phnoms need to be followed by Penh in order to match our regular expression. That is why we call it look ahead. So we have to look ahead, like look to the next sequence after our expression to see if it satisfies our condition or not. If it does, like the substring here, we consider it to match our regular expression. Okay, and for negative look ahead, it is like the opposite. So if I change from the equal sign to exclamation point, so this is negative look ahead. So it means that we need to find Phnom, and the next word, like the next sequence, the next text, the next string, needs to be not pen. So you can see that here it returns the second Phnom instead. All right. So is it clear for everyone about look ahead?
Gesture is like condition.
Yes, it's like condition. Actually, we also have like a look. How do we say opposite of look ahead? Look. Look backward. No. I think there is a mention as well in this documentation. Okay, so here it is look ahead. So we have this one as well. Look behind, right? It is called look behind. So I do not put it in the slide, but we have also this one as well. So the for look ahead, it is a condition after our expression, and for look behind, it means that our expression must follow this condition. So the condition needs to be on the left side of our expression. Okay, so you can read more in the documentation to understand clearly about look ahead and look behind. Because look ahead is more common. That's why I mentioned in our slide. Look behind, it is yes, it is less common. All right, so I think that is all of the basics of regular expression. So yes, if we have exercise to know if you understand how to use a regular expression or not. So we have 9 exercises. So the purpose of this exercise is to write a regular expression to match this pattern. Okay, so the first one is punctuation. So you can see that in our regular expression, we have in order to any character, any digit. What about punctuation? We want to have a regular expression to match a punctuation. So what can we write here? And then the second one, string of letters. Okay, so only letters. So this one, it can be lowercase or uppercase, whose length is at most 3. So it is about the length of the string. The third one, it is about the length of the string as well, at least 3. So it can be longer than 3. And it is strings of digits. So only digits are allowed. The fourth one, string of word characters containing at least one A and one B. So it means that the string can contain uppercase letter, lowercase letter, and also digits. But in order for it to match our regular expression, the string has to have at least one A and at least one B inside. Okay, something like 1, 2, 3, B, C, D. We have one A, and then 4, 5, 6, and then B. You can see we have one A and one B. So the entire string matches our regular expression, matches our pattern. Okay, yeah. Number 5, anything enclosed by square brackets. So something like we have bracket and anything inside is okay. So number 6, string of word characters whose the 5th character from the right end is a digit. Okay, so something like A, B, C, D, and this one is number 1. And this one can be anything like A, B, C, 2, 3, B, something like this. Okay, as you can see, if you count from the right side, 1, 2, 3, 4, 5. So the 5th character from the right side of the string is a digit. So it means that it matches our pattern as well. Number 7, we have to match a string in this format, the date. So year first, you can see four characters for year, and then we have one dash, and then 2 characters for month, another dash, and the last one is 2 characters to represent the day. And you can know that for date we cannot have something like 13, right? Or let's say 21. So we have to consider that as well. And for day we cannot have something like 58. No, only from 00 up until 31. Okay. Yes, these last two. So number 8, strings of 10 digits that starts and end with the same 3-digit sequence. Okay, so for this one, you can use the capture group capture in order to do this one. And the last one, yes, password check. So we have a string that we can use as our password, but we have all of these conditions. So you can see that this one you need to use the look ahead feature in order to do this. So the password needs to satisfy all of these 4 conditions. So the first one, the password needs to have at least 1 lowercase letter, 1 uppercase letter, 1 digit, and at least 6 characters. So this one is like the real condition of how we can create password for some application. So how can we write only like one regular expression in order to satisfy all of this? All right. Okay, so is it good? Is it okay for everyone? Do you have like at least have some idea of how you can do this exercise? Any question?
Teacher, can you explain a little bit about anything enclosed by a square bracket?
Yeah, something like this, like A B C D E A B C D 1 2 3, or you can put punctuation like as long as it is inside bracket. This is the string that we want to accept, that we want to match.
So also the bracket, right?
Yes, including the brackets.
Okay. Okay, sure, got it.
Okay, so any other questions? If there's no question, we can stop here for today's session.
Teacher.
And yes, for this exercise, it is your homework. So you have to submit back by before next session. Okay, so before 1 p.m. next Tuesday. I will create an assignment in Microsoft Teams so that you can submit your work. Okay, so for each exercise, you have to first write the regular expression, and also don't forget to put in some explanation. Okay, so don't just write like yeah.
Do we do it in Word or do we have to
Yes,
write it like in Python?
You can just use Microsoft Word and then just write the regular expression, and below the regular expression you can put in some explanation.
Okay.
Teacher, I want to ask about number 7. like that format. Year. So you mean like we need to have 4 digit right? Every like យើងត្រូវការ4 digit រហូតហ្មងមែនលោកគ្រូ
ណែត្រូវការ4 digit
អត់អាចមានឆ្នាំ999អីចឹងអត់មានទេ
បើ999យើងដាក់0999មក
អូ
ចឹងបើ999ទៅទេអាហ្នឹងក៏យើងគិតថាអាហ្នឹង consider ថាអត់ match ដែរនិយាយទៅតើតាមាន4 digit នៅដំបូងហ្នឹងអាហ្នឹងបើយើងគិតថាវា match but for number 7 you don't have to like for example if this one is 02 like the day can be up until only like 28 or 29 you don't have to take into account this condition because it can be very complicated. So just to try to limit the range of a month from 00 until 12, and for the range of a day from 00 until 31. That is okay. You don't have to think about the other complicated conditions. Okay. So I hope that it is good for everyone. All right. Okay, so let's end today's session and see you again next Tuesday.
Yes, thank you.
Thank you, teacher.